Hey everyone and welcome. Today I want to talk about a really important concept in computer networks, especially in the world where we have so much data. We are going to be talking about DFS, which means a distributed file system. Now, before we jump into slides, let's just think about a problem we all have data. We have so much of it photos, videos, documents, projects. Now, imagine trying to store all that data in just one computer. What happens if that computer's hard drive fails, or what if you are not at home and you need a file? It's a huge problem, right? This is where DFS comes in. It's really smart way to manage massive amount of data and it's actually all around us. So now let's get into it. Okay, so let's look at our first slide. It will be talking about we will be discuss about what DFS is basically. So it is a system that allows users to store and access files across multiple computers that are all connected by network. Instead of all your files being on a one giant hard drive, they all spread out. A piece might be here, a piece might be there. But here's magic part, and this is the second point on the slide. The user, it appears as a single unified file system. My favorite analogy for this is Google Drive or a Dropbox. So when you open a Google Drive, you just see your folders and files right there. So let's say my drive. You don't know if your docs is on a server in California and your vacation photos zip is on a server in Ireland. You don't know, and most importantly, you don't have to care. You just see your files, and that's what we mean by a single unified system. It hides all the complicated stuff in the background. This leads us to three big benefits listed here, which we are going to get into right after this, which are transparency, scalability, and fault tolerance. These are the whole reasons DFS is so powerful. So let's now move on to the next slide. Okay, so now let's discuss the objectives of DFS. The first objective is transparency. Like I just said with the Google Drive example, transparency means file system hides the fact that files are distributed. It's invisible to us. The slide says it perfectly. Users can access and manage files as if they are stored locally. This means we don't have to type in the special IP address of server 1 to get one file and server 2 to get another. We just click the file in the folder. The DFS in the background figures out where that file actually lives or where pieces lives and goes and get it for us. That's the location transparency and it's what makes the files systems easy to use. The second one is reliability. A DFS system designed to be reliable, it's built for with the assumption that hardwares will fail, servers will crash, and disk will die. So, how does it protect our data? The the replications and fault tolerance. These are the keywords. The replication means the system automatically makes multiple copies of your data, let's say three copies, and stores them on different machines. We will definitely think is it so great to do it? It ensures the continuous access. If server A, which has a copy of your file, suddenly fails, it's no problem. The DFS just say oh, server A is down. I'll just get the file from server B. The user, might not even notice a tiny delay. So this is all called fault tolerance. The system can tolerate faults and just keep on working. It also maintains the data consistency, which is fancy way to saying the system works hard to make all the copies that are up to date. So now let's move towards the third objective, which is performance. DFS solves this by balancing the load. Since the data is spread out, the work can be spread out too. If 100 people request file at the same time, the DFS can send 20 requests to server 1, 20 requests to server 2, and so on. No single machine gets overwhelmed with the request. This is another smart trick, which is caching. If you access a file, the system might keep a temporary copy of it somewhere physically closer to you. So next time you ask for it, it's super fast to retrieve. It's all about the reducing the delays and making the system feel quick and responsive. So now let's move towards the fourth point, which is scalability. Imagine your company is small. You have 100, approximately 100 users. Your DFS is fine. What happens when company grows to 10,000 users? Which means when they are scaling up. With a traditional single server system, you have to buy massive, super expensive new servers, and moving all data would be nightmare. With DFS, it becomes very easy task. New machines can be added easily without affecting existing operations. You just add more cheap normal computers to the networks. The system sees the new storage and like definitely start using it. It scales out horizontally, which means which is much easier and cheaper. So now let's move towards the fifth point, which is security. So when our data is on all these different machines, you must control who gets to see it. A DFS isn't just free for all. So it has a strong security rule. It restricts the access to authorized users only. This means you have to log in and systems checks if you have permissions to read a file, whether like it checks all the permissions about to read, whether a permission is given to read, write, or delete. So now let's move towards the next slide, which is basic concepts about DFS. So the first point is files are distributed across different machines, which we already discussed in the previous slide of objectives where we talked about distributed files. So second point is users can access file without knowing their physical locations. We have covered that too in our previous slide. That's our magic word transparency, like we discussed in the previous objectives. The third point is that DFS handles everything. This is main job. It's like a manager in the background. It takes care of file storage and retrieval, figuring out where to put a file, how to get it back, and all those stuff is handled by DFS itself. The second is location transparency, the the part that hides where it puts the files. And the next point, which is very important, is consistency across nodes. This is making sure that if you have multiple copies, replications of a file, they all match. You don't want to get an older version of file from one server and new version from another. The DFS manages this to make sure a data remains consistent. So these are all benefits, objectives about the DFS, that is distributed file system.
So, all right. So, in the last part, Jidnesh talked about what a DFS is and what its goals are, like transparency, reliability, and scalability. Now, let's get into the how does it actually work? What are the moving parts inside? That brings us next to our slide. Okay. So, it's about key components. So, as we can see, there are four components: client, server, metadata server, communication network. These are the four main parts. So uh, this slide shows the key components. Okay. So the first one is client. First, we have the client. This is very simple. All right. So in the last part, Jitesh talked about what a DFS is and what its goals are, like transparency, reliability, and scalability. Now let's get into how. The how part, like how does it work? So in this slide, we'll talk about the key components that makes this a DFS, distributed file system. So the first one is client, server, then there's metadata server and name node, and this communication network. So let's talk about server. So no, so first let's talk about client. First we have the client. This is simple. This is us. It's our computer, my laptop, your phone, etc. It's any device that needs to ask for uh, for a file. Okay. So as the slide says, it's a request file operations. Operation just means read. Okay, read or write. So the client either wants to read that file or write something to it. Then there comes server. Uh, if the client is the one asking, the server is the one that has the stuff. The slide says it stores the actual files and respond to client request. Okay, so client will request for some resources and server someone will provide him the resources. Okay, that's how it works. Then there's the third component, which is metadata server and for name. Now, this third one is the most important part to understand. The metadata server, which is also a name node in the system, like Hadoop. Okay, it's an example of it. So, what is metadata? Metadata is data about data. Uh, let's have this analogy. Uh, let's think of it like a giant library. So, servers will be the bookshelves which will have the data, which will hold the thousands of our files, like thousands of books. That is files. And we are the clients. We want us one specific book in this entire giant library. So how do we find that one particular book? So for that, we will need metadata. Metadata means it will be like any book or indexing, which will keep the track of books. Like there will be a particular section in which the book will be there. That's how metadata really works. Okay, the metadata server doesn't store any book any file itself. It stores information about the book, like about the file in our case, like about the file, and it will tell us, give us a specific path to that file. Okay, like where is the file located? So as the slide shows, it maintains the file location information. When a client says, I want file.txt, it first takes the metadata, takes the metadata, and asks the metadata server. The metadata server checks its log and says, that okay, file.txt is on server file. So we will have multiple servers. So it will be somewhere around the server, and metadata server will give us a route or a path towards the file. Okay. When the client knows to go to one of those servers, then to get that actual file, like metadata server acts as a address book or the brains of the whole operation. So the fourth part is communication network. The communication network. This is the glue that holds everything together. It's the internet, the Wi-Fi, the cables, etc. It's whatever connects the clients and servers, so they can actually talk to each other. Without network, we just have a bunch of lonely computers because there won't be any medium to communicate between them. Okay, this part makes it a system. So now we have understood what are the key components. Now we will move towards the architecture of the distributed file system. So as we can see, uh, next, uh, actually we have this architecture of a DFS. Okay, so now that we know the components, right? Let's talk about the diagram if you say. On the left, we have the clients. Okay. Here we have the clients. On the right side, we have the servers. There's a storage area network, and those are connected towards the databases. Okay. Here we have our DNS. All our files are being stored here. Okay. So what will happen usually that whenever the client asks for something, it comes to the storage area network. There might be the metadata server and all, or if the request comes from the servers. It will then check where the file will is. It asks to the particular server, and then that server returns data and give it back to the client. Okay. So that's how it works. Okay, so let's go it more specific. Suppose there's a client on left, suppose over here, there's a client in the top left. He needs a file. So what he will do? He will send a request to the server cluster. Okay, so here we have the server cluster. And this is the brain of our architecture. Okay, these are entire systems. It acts as a brain. So the server cluster, it also has the metadata server part. So it will look up to the address of the file. Like as the metadata server will tell us on which server the file exactly is. Okay. So it looks up to the file and finds out that the file that the client wants is somewhere in the disk one or two. Okay, disk one and two. So here they have some disk. So our request will go to them. Okay, the server cluster then goes to the storage area network, grabs the data from those disks, assembles the files, and sends it back to the client. Okay, so that's how it works. Like first client then goes to the server, and then metadata that identifies where the storage, where the file is. Then what happens is the request goes to the storage area network. It then takes returns data from the disk and gives it as a response to the client. So that's how it usually works. The main idea here is that the brains, that is here, the server clusters, are separate from the storage user network. This lets us add more storage or more brain power independently, which is a very smart scalable design. Like we can scale the server separately and the storage separately. It gives us more flexibility. Okay. Now we understood the architecture of DFS. Now let's move on and understand the basic. What are the features of DFS? Uh, so let's see the main features of DFS. The features are the result of that architecture and those components we just talked about. The first one is location transparency. We have said this one a lot, but it means the user sees the same path, like my drive, photos, and it doesn't matter if the file is on server 1 or server 2. The user will see a simple interface, but at the back end, the files might be distributed on various servers, right? So user don't know about it, what the backend part. Location is transparent or invisible. The second is replication. This is our reliability feature. The system makes copies of files on multiple servers. Why? Why it makes multiple files? So if one server fails, another server still has that particular file and can respond back to the client. Okay, that's how. But replication is needed. So as a backup, it is basically like as a backup. Then there's the third feature as concurrency control. Like concurrency means like having the same thing running multiple times or simultaneously parallel. That's what we call concurrency control. Concurrence means at the same time. This feature is what allows multiple users to access the same file simultaneously. So if there's one file and there are multiple users who wants to access them. So this particular feature helps us to maintain the concurrency. Like one is already using, so we can't just stop. So with concurrency, we can share that same file to the other users too. So okay, the system has to be smart about it. So if you and I try to edit the same file, the same document at the same second, the system needs a rule of control, like operational controls. Like if I edit something, it has to get edited, and then we will be able to see if we are editing at the same time. That needs to be done properly, or else it will leads to data deletion or data missing. Okay. The next feature, the fourth one, is about fault tolerance. So this is the result of replication. Because we have four copies, the system can tolerate faults. It continues operation after failure. One server down is not a catastrophe. It's just a normal day, and the system keeps warning, working. Security and access control. And finally, this is all about authentication and permissions you are in. So to put together the key components like the client server and the all important metadata server, the network are all the features are the components of the DFS.
Okay, so now we have seen the components as Pratik explained, the architecture and the features of the DFS. We know what it's supposed to do, but like any technology, it's not perfect. It's a system of trade-offs, right? So the next slide is very important. Let's talk about advantages and disadvantages. So we are on the slide 7, and so let's start with the good news, the advantages, right? Many of these are the results of the features we just discussed. Firstly, the efficient file storage, right? This is the whole point actually, because the system is centralized from user's point of view. The incredible ease of many users, even the different countries to access share the same set of files. Okay. So coming to the second point, the high reliability and availability. We talked about this. This comes from a reapplication by making multiple copies. The system is highly available, meaning it's always on and ready for you and reliable because even if one or two servers fail, your data will still be safe and accessible because of high reliability and availability. And coming to the third point, load balancing across multiple servers. This is huge performance win actually. The system is smart enough to not send all the requests to one poor overworked server. It spreads the work of the load across the machines. So even runs faster and smoother for everyone. And the last point which I'm supposed to explain is easy scalability and maintenance. This is that scalability objective that if you need more storage, you just add a cheap server and you don't need to shut the whole server down for maintenance to upgrade it. You can grow it and fix it while it's still running, right? So, but we have to be realistic actually. Let's talk about the disadvantages of the challenges, right? So, coming to the disadvantages, the first disadvantage is complex design to explain the complex design to maintain, right? So this is the big one. All the magic, replication, transparency, tolerance fault, the stuff is incredibly complicated to build. Writing the software to manage all the machines, handle failures, and keep the data consistent is massive engineering challenge actually. And the second point is network dependency. A DFS is a network system. This means it's only as good as your network connection. If your Wi-Fi is slow or your internet goes down, the whole system actually feels slow and stop working. So this is a big disadvantage actually compared to the file on your own local C drive, which works even with no internet, right? So coming to the third disadvantage, that is consistency issue in replicated files. Then this one is bit tricky actually, but it's important actually that imagine we have three copies of a file, right? You edit copy one, how long does it take for the system to update the copy two and copy three? What happens if I try to read the file before it's upload and if I get actually older version? This consistency issue, right? Making sure all copies are always perfectly in sync and all the time is extremely difficult, right? And the last disadvantage which you can say is security management is challenging. In a simple system, one server, you build a strong and wall around it. In a TFS, you have hundred of and thousands of servers actually. That thousands of doors and windows have to be protected and managing permission and protecting data across many machines, right? So much more challenging, right? So so we'll go to the slide 8, right? So this is this is our slide 8 actually, examples and distributed file systems. So all this might even seem very abstract. So last slide example like distributed file system will make it real actually. These are the actual systems that run around the world. First is HDFS, that is Hadoop distributed file system. If you have never heard about the big term, big data, we have heard about HDFS, right? This is the file system used by Hadoop and it's designed to store petabytes of data. Think massive logs from actually, massive logs like storing petabytes of data and from websites or scientific data and analyze it in place, right? And the second is GFS, right? Google File System. This is one of all the data, even if you don't know it. GFS or its new version is the foundation that built Google actually. So it's used for everything Gmail, Google services, YouTube, and Google Photos. And the third is NFS, Network File System. This one is of original. You've seen it a lot in companies or universities. It's how a whole office or a computer can access share drives actually. So uh, it's how a whole companies or apps can share drive, and that's actually a single server down that hall, right? And the last point, fourth, is AFS, Andrew File System. This was also a big one and developed by university and used a lot in academic research settings for sharing files across the campus. And that's okay. So we have seen that GFS to tie everything we have learned together. Let's take a real world example, right? Google Photos. The first is the client. You take a photo on your phone is client. And the second request you can say is the request. You open the Google Photo app, the phone, the client sends a request to a Google metadata or name, and it says even show the photo. And this was all example which you can say, and we'll wind up with this. So that's all. Thank you so much. This was the last slide, and as we have already seen the real world example, thank you.